All right. Good afternoon, everyone, and welcome to MOS Live, to our virtual planetarium exploring space. My name is Becca. My pronouns are she and her, and I'm an educator at the Museum of Science in Boston. Today, I will be your moderator. So what that means is I will be sort of checking the Q&A and passing any questions on to our educators today, or also reading out any responses that they may ask questions of you for. I do want to note that if you are on Facebook or YouTube, we are very excited that you're joining us. However, we cannot see any questions or comments that you post on those sites during the presentation, but we hope that you enjoy following along with us. If you're on Zoom and would like to submit a question or responses to our educators, you can type that into the Q&A box at the bottom or top of your screen. And if you're joining us on Zoom and would like to see captions, you can go ahead and click on the close caption button and click show subtitles. So with that, I think it is just about time that we get introduced to our educators and begin the show.
Hello, everybody. My name is Talia. I use she, her pronouns, and I am going to be your educator today, which means I'm going to be doing most of the talking, but I really can't do this by myself.
Hi, everyone. My name is Katie. My pronouns are she and her, and today I will be your pilot flying you through space.
And today we are continuing our theme for the month, which is sort of taking a look at our solar system's history and how it has changed over time. So if we could go ahead and highlight or spotlight Katie's video, we will see what our solar system looks like today. And last week, what we did was we looked at how the positions of the planets actually changed a lot in the very early solar system. What we're going to be doing today is talking about how some of the planets themselves have changed over time. Now, when you think about planets changing, evolving over time, are there any that in particular would jump out to you when you think of that? Because we don't often think of planets changing over time. But if you were to think of like, oh, planets that have changed a lot or evolved a lot over time, which planets, if any, would come to mind? Go ahead and put your answers in the Q&A, and you can always put question marks if you don't know, or if I ever ask a question that you don't know an answer to, you can feel free. But if you're thinking about planets changing and evolving.
Awesome. So we do have a lot of people so far saying the Earth, also some answers for Mars, some question marks, and maybe even Saturn or Pluto and Venus. So we're getting a lot of answers.
We're getting all of them. All right, excellent. Well, and that's because planets do change over time. So I'm going to focus on 3 planets today, and we're going to start with the one that a lot of people sort of think of when they think of changing planets, because I think its story is one of the more well-known as we think about studying planets and how they've changed, and that is our neighbor, the red planet, Mars. So Katie is going to actually fly us to Mars, and we can see what Mars looks like today. So today, Mars is a very cold desert. You know, we usually think of deserts as being very, very hot. A desert is anywhere there isn't a lot of moisture, and Mars certainly qualifies. So even though Mars today is quite cold, cold enough that any water that's left is frozen pretty much. And it is cold because it has a very, very, very thin atmosphere, thin layer of atmosphere, about 1% as thick as Earth's, which plays a big role in Mars being as cold as it is, because atmospheres are actually blankets for their planets, and they trap heat and keep the surface warmer. So this is Mars today, a very cold, very, very dry planet with a very thin layer of atmosphere. But in the past, Mars looked quite different. We have evidence that in the past, Mars had a lot of liquid water on its surface. Would have looked maybe more like this. This is an artist's rendition of what Mars might have once looked like. Lots of water, especially in the northern hemisphere. We think the northern hemisphere may have been a giant ocean. And just the fact that there was liquid water means that Mars necessarily must have been warmer, because now it's too cold for there to be this much liquid water on the surface. And it must have one of the reasons it must have been warmer was because it probably had a much thicker atmosphere. So Mars would have looked very, very different in the past than it does today. So the question sort of then becomes, how do we know that? Because if all we have is what Mars looks like today, how do we know that it once would have looked a little bit more like this? Well, fortunately for us, Mars is a place where we can, I say easily, it's not actually easy. We can send rovers to Mars. And some rovers have had a lot of success finding evidence for water that once flowed on the surface. Here's actually some evidence from, you can see from orbit, from our orbiters, because we have a fleet of orbiters going around Mars, including the Mars Odyssey, the Mars Reconnaissance Orbiter, the MAVEN, the Mars Atmosphere, something. And those are just the NASA ones. There's also ones from other countries as well. There's a small fleet of spacecraft going around Mars right now. And you can see things like river channels here. On the left is a river from Earth. So that is a river with water in it on Earth that was seen from space. And on the right, a river channel on Mars. And you can see they are very similar in appearance. And that's not the only sort of side-by-side thing that we see on Earth and on Mars, indicating that there was once the presence of water. Where you have rivers, for instance, you often have river deltas. And here's a delta on the left. There's a delta on Earth. In this case, it's in Puget Sound. And then on the right, a delta with no water anymore, as seen from orbit on Mars. And this is one of the ways that we choose where we're going to send our Mars landing craft, our landers and our rovers. Because one of the things we're very interested in are these areas of Mars that we think were once very wet, that had a lot of liquid on in their vicinity. And so we look for things like river deltas. This is how we chose where Curiosity, the big rover, Curiosity landed. It landed in what we think used to be maybe a lake. Same with Perseverance, the rover that landed just in February. It landed in Jezero Crater, which we also think used to be a lake. So this is a great way for us to figure out where to land our rovers by looking for places where we see these water patterns. And then once the rovers are there, they can get up close and personal with the ground. And there we find even more evidence. So two rovers I haven't really mentioned yet, the Mars exploration rovers Spirit and Opportunity, went a long way towards proving that there had in fact been large amounts of liquid on Mars by finding in the ground things like clay minerals, hematite nodules, things that only form in the presence of water. So these are from the Opportunity mission, I think, might be Spirit, I think it's Opportunity. And these are what they nicknamed the blueberries. And they are nodules of hematite, which is a mineral. And you see things like this forming in the presence of water. And you can see the rover found a lot of them. Mars has quite a few of these in certain places. So this is all evidence that Mars in the past was a very different place, a much warmer planet, a wetter planet. The question then sort of becomes, how long was it like that? And that we still don't know the answer to. That's a question I cannot tell you the answer to. There are some theories that Mars only kept its oceans for a short amount of time. There are other theories that it would have kept it for quite a long time. So we're not, and there are some theories that it was warm and wet, and some that it was just sort of cool and wet, not freezing the way it is now, but just sort of cool and wet. So exactly how comfortable you would be if we dropped you down on the surface of ancient Mars is still to be determined, but we can definitely determine that Mars once had large amounts of liquid water on its surface. One of the reasons we are so interested in sending rovers to study these places, because maybe it had the right conditions to support life. And so maybe it did. We don't know, and that's why we keep looking. By the way, I should point out that there are pictures of those nodules going around the web with somebody claiming that they are evidence of mushrooms on Mars. They are not. For the record, what you're seeing when you look at those pictures are in fact these hematite nodules. So just in case you see those headlines anywhere, they're not mushrooms. They are little mineral balls on Mars. But yes, so Mars today, a very, very different place. And in this case, we think it's because Mars lost its global magnetic field. Again, we can tell by looking at the rocks that Mars used to have a magnetic field like Earth does, and that actually protects us from the solar wind. And having lost its magnetic field, it began to lose its atmosphere to this solar wind, giving Mars a much thinner atmosphere. This makes the surface much colder, makes it much harder for liquid to remain a liquid on the surface, and gives us the cold, dry Mars that we see today. So that's one of our neighbors, the red planet Mars. Of course, we do have another neighbor, and its name also popped up when I asked you earlier about what planets you thought of when you think of evolving planets. Our other neighbor, of course, is the planet Venus. Now, Venus doesn't get quite as much attention as Mars. It's harder for us to send spacecraft to Venus. We don't often send them down to the surface because they don't survive very long. At least historically, they have not. Venus is a very different place than Mars is. In fact, what you're seeing here, this is actually not the surface of Venus. You're seeing the tops of the clouds. The atmosphere is so thick that you can't see the surface of Mars. So that's one way, or of Venus. So that is one way it's very, very different from Mars. Mars has this very, 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 very thin atmosphere. Venus has this extraordinarily thick atmosphere that you can't actually even see through. And I told you, atmospheres are like blankets. Mars has a terrible blanket. Venus has a very overactive blanket. Venus is hot. It is actually the hottest planet in the solar system, even though Mercury is closer to the sun, because Mercury doesn't have an atmosphere to be a blanket for it. So fortunately, we have sent spacecraft to Venus to go and orbit around it. We actually have been able to look through that atmosphere to see the surface of Venus and see what this planet looks like under the clouds. And it's, as you might imagine, a desert. So that's one thing it does have in common with Mars. The surface of Venus is somewhere around 800 degrees Fahrenheit. And that means there's really no liquid water on Venus. In fact, there's barely even, there are a few wisps of water vapor in the atmosphere. And that's really the only water that you find on Venus. So it doesn't even have ice packs like Mars does because it's far too hot. However, we think if you go back in the solar system's history, like Mars, Venus was a much nicer place. And quite possibly, like Mars, had an ocean on its surface. So made it look maybe more like this. Again, this is an artist's rendition of what we think Venus might have looked like in the past. So that's a very big dramatic shift. And in kind of the opposite direction of Mars. Mars sort of slowly froze to death. Venus, we know, went from something that looked like this to the very, very hot, steamy planet that we have today. Now, when we were talking about Mars, we were able to show you lots of the evidence from our orbiters and from our rovers and landers that tell us that Mars once had liquid water on the surface. We don't really have that when it comes to Venus. We think Venus had once looked a lot more like this because of models. So we run computer simulations a lot, especially about the early solar system, how the planets formed, how they got to where they are, and how they became the planets that we see today. And when you look at the solar system, you look at Venus's size, which is very close to the Earth. Their Earth is just slightly bigger than Venus. So you look at the size of Venus compared to Earth, and you look at the placement of Venus in the solar system compared to Earth, they're almost exactly the same size, and they are very close to each other. So Venus is closer to the sun than we are, but it is actually very close to us. It's our closest neighbor, in fact. Venus is closer to us than Mars is. So that suggests, and models bear this out when we run models of the formation of the solar system, it bears out the idea that like Venus, early in its history, had oceans, and it would have had a much more Earth-like atmosphere than we see today. So then the question becomes, what happened? And what happened sort of depends on which model you look at. Because we're basing this off of models of Venus. Different models suggest different amounts of time that the oceans lasted. Kind of like we don't know how long Mars's oceans last. We think that either Venus's atmospheres maybe only lasted a few million years, which sounds like a very long time to a human, but is in fact a very short time for a planet. Or maybe it lasted a few billion years. Maybe Venus would have looked like this as recently as 700 million years ago. Again, that sounds like forever for a human, but it's not so long ago to a planet. It would actually be quite remarkable if Venus had changed that much in only the last 700 million years. So then we have to sort of try and figure out what happened. What made Venus change so dramatically? And it, again, depends if you're working with a model that suggests that it lost its oceans early or late. When you look at the early loss model, so when Venus only had oceans for a few million years, the model suggests that maybe it was the sun's fault, that the heat from the sun actually caused increasing amounts of radiation, or of evaporation rather, of the oceans, and that radiation from the sun caused all those water molecules in the atmosphere to split. Because water is H2O, hydrogen and oxygen, it actually would split into the hydrogen and the oxygen. The hydrogen was lost to space. You don't see a lot of it on Venus today. And that leaves the oxygen, which would combine with carbon to form CO2, carbon dioxide, which is a greenhouse gas. And once that starts going, that process just keeps on going. And you get the thick carbon dioxide atmosphere that you see today on Venus, which is very, very, very hot. So perfect for a planet where the greenhouse effect has gone amok. And then there's the other theory suggesting what might have happened if the late loss model, if Venus actually looked like this until relatively recently in history. We think Venus had a major volcanic event about a few hundred million years ago. And that major volcanic event, one thing that volcanoes tend to do is outgas carbon dioxide from the crust. There's a lot of carbon dioxide stored in the crust of Earth, for instance. And one way for it to get out is through volcanoes. So we know that Venus was definitely volcanically active in the past. It may still be volcanically active today. And Katie has actually positioned us nicely. Those dark patches that you can see, those are volcanoes. The dark patches are lava fields surrounding a volcano. And we think a few hundred million years ago, there was a major volcanic event on Venus that could have released a whole bunch of the CO2 stored in the crust, causing a mass release of CO2 all at once, and very quickly turning Venus into the planet that we see today with this really thick, dense CO2 atmosphere and this surface that is hotter than an oven. We do know similar very major volcanic events have happened in the past on Earth, so it's not completely crazy. This would have had to be a huge event, though, to completely change the atmosphere. But maybe that's what happened. So I've got one more planet to get to, and it is my favorite planet. It is the Earth. As we fly there, Becca, have any questions rolled in that I should try and answer about Venus or Mars before we move on to Earth, or should we just go to Earth and save questions for the end?
There have been quite a few questions that have come in, and I guess as we kind of transition, one that kind of relates to both of them was, so why was water so prevalent on both of them? And also kind of in that, as a follow-up, why was water so prevalent in the early solar system and now it's not?
That is a great question. Water is abundant in the solar system. If you're looking for any form of it, that's vapor, liquid, or ice, there is ice everywhere. There is a lot of water in the solar system. And we think early in the solar system's history, Earth got its water partially from the rocks from which it actually formed, and maybe partially from being impacted by icy comets. So that was happening to Earth. It means it was also happening to Mars and Venus, because again, they're very close together in the solar system. We tend to think of them as being very far away, and for human distances, they are. But in space distances, they're quite close together. So if Earth had this mechanism to gain oceans early in the solar system from the rocks that it formed from and from ice being delivered from the outer solar system by asteroids and comets, Mars and Venus also did. So that is why if Earth can have oceans, basically, probably Mars and Venus could have at similar points early in the solar system's history as well. Was that the whole question, Becca, or was there another part of it?
I think you pretty much covered that.
Okay.
And there are other questions, but I don't know if you want to talk about Earth first, and then we'll get to some of them.
We'll talk about Earth first, and then we will have some time for questions at the end. Earth, of course, has changed a lot over time. For instance, when it first formed, it had oceans very early in its history, but its atmosphere was toxic. We would not have survived on very early Earth. In fact, pretty much no life that we see on the surface now would have survived. But fortunately for us, we did have those oceans, and life could form and survive in the ocean. And some of that life in the ocean invented photosynthesis, or rather it evolved to use photosynthesis as a way to gain energy. A byproduct of photosynthesis is oxygen, and that caused a huge release of oxygen into Earth's atmosphere. This was a major event in Earth's history, the oxygenation of the atmosphere. And it's actually one of the ways we suggest that maybe we could look for life elsewhere on exoplanets in other solar systems, is by looking for this dramatic change, this dramatic increase in oxygen. That is why life can survive out of the water today on Earth. So its atmosphere has changed a lot over time. And that made it also possible, when we look at Venus and we look at Mars, the changes in the surface really are due to changes in the atmosphere, what happened to the atmospheres. That is partially true for Earth as well. Earth's changing atmosphere will affect its surface. But Earth's surface can actually change all on its own in ways that we don't really see on Mars or Venus. Now, Mars and Venus both have volcanism, or had volcanism, maybe still do, like Earth does. Earth also has earthquakes. It has plate tectonics. Things like this will all affect the surface of the Earth and how it changes. And we actually think it has changed many times over time. We think there are periods in Earth's history in which the entire surface of Earth was quite warm. Even the poles would have been nice and warm and had lots of plants on them. We also think there are periods in its history where it did the opposite, where the entirety of the Earth may have frozen over into what we call Snowball Earth, which is a concept I find fascinating. Maybe twice, I think, in its history. I'm saying this because with uncertainty, because Becca knows way more about the history of Earth than I do. We think maybe twice in its history, Earth may have been a snowball Earth. And if we were sort of like Venus or Mars, a major change like this might have caused us to stay stuck like that. But there's something going on Earth that never was going on Venus or Mars, and that is plate tectonics. Earth's land masses are constantly moving around. And one of the ways that the grip of Snowball Earth may have been let go is that more landmass got moved into the equatorial regions. So Earth's shifting land masses will also affect its surface. Katie is running a simulation of how we think the position of the land masses have changed over time. And it's very dramatic. You go back even a few 100 million years ago, and you would not recognize the Earth. I say, again, that's not very long for a planet. We're at the start of the dinosaurs right now. We're going to keep going back even farther to a time when that was even before the dinosaurs. And Earth is constantly changing. Earth's surface, the land masses are constantly moving around, which means Earth doesn't get stuck necessarily in one sort of environment the way Mars and Venus did, which is one big advantage that we have. So it's going to stop about 750 million years ago, which again sounds like forever, but isn't. Not for a planet. That's actually still fairly recent. So Earth is still changing today. This video is going back in time, but Earth is still changing today. It is still evolving. It's not stuck the way Mars and Venus is in a sort of a single state. Earth can still change. Earth is changing. It is constantly changing. So our planet is still evolving today. And I did want to leave some time for questions. Becca, go ahead and throw some questions at me.
Sure, we have so many, and I have to say it's really cool talking about all of this. So we have sort of questions about Venus and Mars again. So why and how did Mars' atmosphere change? But kind of related, why did one planet get colder while the other got hotter of our neighbors?
Basically, it's because one lost its atmosphere and one gained an atmosphere that is heavy in greenhouse gases. So we think Mars, as part of its evolution, its liquid core, the very center of the planet, solidified, which means it can't generate a magnetic field anymore. Earth has a magnetic field. We mostly don't notice it. It's why our compasses work. It's why we have things like the northern lights. But it also protects our planet from the solar wind, which is just this stream of particles constantly coming off of the sun. Again, we don't notice it because Earth has this magnetic field. If Earth didn't, that solar wind would actually start stripping away Earth's atmosphere. And that's what we think happened to Mars. Mars, once it lost its field, it lost that protection and it started to lose its atmosphere. As its atmosphere got thinner and thinner and thinner, that's like having a worse and worse and worse and worse blanket. So the surface gets colder and colder and colder and colder. Out at Venus, what you have at some point, for some reason, is a dramatic increase in the amount of CO2 or carbon dioxide in the atmosphere. That's a greenhouse gas. It is very good at trapping heat. It essentially makes the atmosphere a much better blanket. That makes it easier for more CO2 to be generated into the atmosphere. It's a runaway effect. And that means that Venus just kept getting this thicker and thicker and thicker and thicker and thicker blanket of like of gases, very, very good at trapping heat. So basically one lost its atmosphere, one got too much atmosphere of the wrong kind of gas.
Too much atmosphere, too little, and then just right.
Just right.
So since we only have time for one more question, unfortunately we have so many and they're all really great. I wish we could answer all of them. But for this last question, it's a good one to end on, thinking about the future of our planet. Someone's asking, will Earth end up like Venus or Mars in the future?
It will eventually become uninhabitable, and that is inevitable because of the way the sun is going to evolve. The sun is going to, just as it gets older, it's going to start throwing out even more heat. We think we've got maybe 1 billion years before Earth is too hot to maintain an ocean. So that's about 1 billion years in the future. Don't change your weekend plans. And at some point, that is also going to cause the atmosphere to change dramatically. And that'll initially probably be a much hotter atmosphere. Eventually, it's possible that the sun could just bake the atmosphere away entirely. This is, again, all billions of years in the future, but yeah, Earth is not going to stay the pleasant blue marble that it is today. Given enough time, it's going to get everything in the inner solar system is going to get baked by the sun. It's just part of the circle of stellar life.
The circle of stellar life. Awesome, Talia. Thank you for that. And thank you, Katie, as well. Unfortunately, we did run out of time, so we do not have any more time for questions, as much as I would love to answer all of them. But I do want to give you two the opportunity to say your goodbyes as well.
Hi, everybody. Thank you so much for coming.
Bye, everyone.
Thank you to both of you for showing us a lot about space today and for talking about our planet and neighboring planets. If you all enjoyed this, I do hope that you come back to another program of these in the future. So you can go to mos.org/MOS at home so you can check out our next programs and anything we have. You could also go ahead and check out some of the programming that Katie was using by going to NASA's EYES. And also you could check out what we have to offer at the museum. And if you were interested in donating to the museum or supporting MOS at home or any other museum things, you could head to engage.mos.org/welcome. So I want to thank you all so much for coming today and enjoy the rest of your day. Bye, everyone.